Welcome to the stage, Rick Venzosa, the moderator of the next session.
Well, good morning, good afternoon, or good evening. Welcome and thank you for joining us for today's final session, the current state and capabilities of real-time industrial IoT platforms. If you're new to this event, take a look at the layout of the event tool. Please feel free to use the chat to tell us where you're located. If you have questions for our panel, and we'll be handling questions at the end, please use the Q&A tab on the right-hand side, not the chat. This conference session will run about 59 minutes. Hi, I'm Rick Franzosa, your moderator today. I was a Gartner analyst for the last 10 years, covering manufacturing technologies for the Supply Chain Research Group. Prior to that, I was part of a number of software companies that focused on manufacturing technologies such as MES, shop floor control, electronic work instructions, and PLM. We have four incredible speakers today. I will have them introduce themselves, starting with Shin Nakamura, president of Daiwa Steel Tube Industries.
Hi, my name is Shin Nakamura. I'm coming in from Japan right now. I'm a third generation manufacturer from Japan. We have one operation in Japan and also in Vietnam right now, and we do some more, development for the system, development for the IoT platform, or industrial 4.0, 5.0 approach right now. Great to meet you here. Thank you.
Thanks, Shin. Next, we have Erica Franco, solution architect for industrial IoT at Cisco.
Thank you, Rick, and good afternoon, everybody. I am a solutions architect specializing on industrial IoT at Cisco, but I have spent about 7 years working at the intersection of networking and operational technology. My role is to design networks so that will empower factories to adopt cutting-edge technologies like virtualization, AI, real-time analytics. So I believe going through digital transformation depends on the ability to bridge these operational needs with a robust network design, and I'm thrilled to share the insights today. I'm not only bringing my passion for networking, but also my Colombian accent. So I hope that that's a little bit of diversity to this conversation.
Thanks, Erica. Next, we have Zev Arnold, Principal Director from Accenture.
Thanks, Rick. So I'm Zev Arnold. I'm a Principal Director with Accenture's Industry X, which is the business within Accenture that helps our clients reimagine the things they make and how they make them. I consider myself a practitioner of the fourth industrial revolution. I've spent almost my entire career with one leg in OT, one leg in IT, desperately trying to cross the boundaries and trying to pull those together. I feel most at home on a computer in a plant, which maybe fits my explanation. I'll also mention I'm sharing my own perspectives here and experiences as best I can. I'm not necessarily representing Accenture's official views.
Thank you, Zev. And finally, Jerry Abbey, Director of Product Marketing from Copia Automation.
Hi, everybody. As Rick said, Director of Product Marketing at Copia, and previously I was at Rockwell Automation leading Global Industry Analyst Relations. So I got to work with Rick a lot on that and look at a huge portfolio of different technologies. As part of my role the last 4 years, I've been running research reports. I love data. I've always loved data, and digging into the state of smart manufacturing and currently digging into the state of industrial DevOps, which is helping to converge that IIoT space that Zev mentioned. So I'll be talking a lot about that and thinking about all of this conversation today as I've been working on it for the last several years in depth.
All right, so we're going to get started now. Like all technologies, IIoT hit the ground with a lot of hype, a lot of promise, so much so that it was hard to see what was practical and what was hype. So we're going to start by setting the context for the capabilities of real-time IIoT platforms. So this first question is for Zev Arnold. What are the capabilities that make up an IIoT platform?
Great, thanks, Rick. It's a good place to start. What is an IIoT platform? I'm going to start with what it is we need an IIoT platform to do, and kind of back into some of the specific capabilities that I think are really important. And what an IIoT platform needs to do, what a business really needs, is to help, I think, two things. One is to bridge the divide of what I've described as the data mega silos of information technology data, operational technology data, and also engineering technology data, right? Which we don't talk about quite as much. These are the P&IDs and file cabinets. It's the equipment specifications, the kind of stuff that capital projects is really good at managing and production operations is really bad at managing. So if we think about those three data mega silos, an industrial IoT platform takes that OT data and makes it available. To do what? To help companies radically change and radically reimagine themselves to adapt to a changing environment around them. I think what I've seen in my clients, and I think we've seen this around the world, is that the pace of business is accelerating. Almost cliche to say, but the supply chain disruptions, climate change, environmental regulations, the demands of our workers and of our customers, these things are changing faster and faster, more radically, not to mention the change of technical capabilities, right? The technology that we can take advantage of. What we need in an industrial IoT platform is something that'll help us respond, as manufacturers, to the physical world. How can I change the changes in the physical world, make changes both in how I'm operating and also the kinds of things I want to do? If we think about analogously, the information technology sphere, we've had a wave of transformation for ERP systems for 20, 30 years that has helped our businesses change and adapt to changes in business, change in business transactions. OT allows us to change to the physical world, and it's very exciting, and it can be, I think, radically beneficial to those who get it right. But to your point, a lot of folks have been stuck in a bit of a pilot purgatory in industrial IoT. I was mentioning earlier some of Gartner's research when we were chatting beforehand. Gartner has their hype cycles. I think industrial IoT right now is in the trough of disillusionment in the hype cycle, and perhaps so. And so I think all of us on this call are committed to pushing it up that slope. And so what capabilities do we need? I think there's some capabilities that come very quickly to mind. We need to be able to collect data from everything. Any sensor that can automatically detect the state of the physical world, we need to collect the data, we need to store it, we need to move it securely through networking layers. To make it available to the rest of the enterprise, and we need to have some basic consumption ability, visualization and dashboarding. But that's table stakes, right? We have that. We've had that for a long time, but we're not getting value out of it, because what we really need is a way to take that data and turn it into events of interest. What is an event that my business cares about? As the physical world changes, what do I need to know in order to take some action that would be different from an action I would take otherwise? I need to know a particular piece of equipment is on the verge of failure so I can change my maintenance. I need to understand how to optimize my capital spend. Maybe I'm trying to rapidly deploy new plants, and I need to understand where best to deploy them and also get them integrated. So the industrial IoT platform, the core capability is turning observations from the physical world into business relevant events that we can use to change the behavior in our business.
So you mentioned the patient zero condition-based maintenance, but we know where the capabilities are mature today. But what are the gaps that you see in IIoT platforms?
So we've got a lot of application disparity in the space. We have a lot of point solutions. Right? We have, you can go to GE and you can get a tremendous application. I'm just calling them out because everybody knows GE does compressors. That you can get a tremendous application for compressor maintenance. That's not an industrial IoT platform. It's an application that uses OT data. And so what can you do with that data? Well, you can monitor your compressors and not much else. A lot of the applications we're used to thinking of in the OT space are really applications, not general purpose platforms. MES helps us organize and track the flow of our orders and our recipes and our manufacturing plants. It is an application. It's not an industrial IoT platform itself. The capability gap is, how do I, in a general sense, organize this data and turn it into these events? It's something, last time I talked to an IIoT world, we were talking about how this is an impossible problem to solve with just computers until you have general purpose, general AI. And I literally said that the day ChatGPT was released. So we don't have general AI yet. There's a huge world of opportunity that artificial intelligence is opening us up for us to automatically derive those business relevant events from the data. So I think there's a big opportunity there to apply technology. But even without applying technology, we start with business process, because technology isn't going to do anything we can't do ourselves with pen and paper, right? And good process. And we can go a long way further than most of us have today just by getting good process in on top of that OT data, working with engineers, helping them rethink, reimagine their jobs as digital natives rather than as direct pen and paper engineers, rather than turning a wrench on training a computer to detect the thing that's interesting. The more we can retrain our workforce to think of themselves as digital workers, I think the more we can make progress very quickly. But I think the capability gap is there. It's in contextualization and events.
Thanks a lot, Zev. Jerry, in practical terms, what does a successful ITOT convergence look like within an industrial automation context and in the world of IIoT? Can you share an example?
Absolutely. That's a big question, Rick. So I'll try and unpack pieces at a time. But building off of what Zev just ended on, and a lot of what you were saying, workforce is the heart of all of this. And getting the workforce bought into the technology that you're bringing in is the number one thing. And we talk so much about ITOT convergence. When does it evolve to ITOT maturity and architectural maturity within how organizations are set up, so that IT and OT aren't these competing forces? Currently, for example, Copia is an industrial DevOps platform. We're trying to bring DevOps into the space. What DevOps came from is development and operations being totally separate, and the software development process taking like one deployment a year, and moving that by joining these two separate groups and doing deployments, multiple deployments a day. And I think for us to really evolve from the ITOT discussion and to take advantage of the IIoT platform, we need to evolve our language around it and move from convergence to re-architecting what we see as the future of organizations. Going back, I've referenced this all the time, but I love The Goal by Eli Goldratt. And I think while it is aged, it is decades old, it has never been more relevant.
Right.
Everyone has one goal, and that is to make your organization profitable, to produce value for the consumer, and then to capture that value. And when all the different groups can understand that and move in the same direction, then we can take advantage of these technologies. But there's so much to unpack, especially when you ask the practical use case. How do we do that? We've been throwing technologies over the wall at our IT functions, at our OT functions. We've created the function of CISO, our security officer, and they're not necessarily working in lockstep. So you might have OT bringing in a certain technology that they want to use. They want to bring in cameras that they can set up and say, this is what quality looks like, bring in AI, train that. But then they're behind this DMZ, which is how OT has traditionally been set up to be segmented so that a hacker can't get in there and create havoc and shut down your operations, cause the safety issues, like number one, thinking about your people. So I know I just said a lot of different things there, but at the end of the day, getting people to move together in a common direction with a common goal is the best way to have an impact with any technology, but especially taking advantage of IIoT today.
Great, thank you. Thank you. I want to turn to a more practical perspective. We have a lot of software people here, but I want to turn to Shin to hear about the biggest challenges that your team faces in manufacturing when integrating real-time data analytics from IIoT sensors into your existing systems?
Yeah, everybody said this right, and also the toughest thing is get the result out. Get that, some savings or whatsoever. Basically, we are making steel tubing, galvanized steel tubing. So we really want to make sure the better yield, higher uptime, and also, reduce the changeover time. But using system is, how to, make those to be more, stable, accurate, faster, and biggest challenge for us is actually integration of the system, contents, and workflow, especially workflow. Because, even though we have a, good system, we need to have some data information to change the operation somehow in a workflow for us. So I think if we get the real-time, data feed, how to, change those relation or connection somehow is a very tough thing to do, and takes a bit more time to, make it happen, especially for not only for the, physical action, more for like a mindset of the people and operator and engineers. So other thing is, we already have, some of the information data on plant floor. So like monitors and also panels, they already have a data. But new, IIoT platform, we soak up some of the information and showing the slightly different way. Sometimes, those data doesn't match very accurately, and the operators got a little bit confused for which one we should follow and how we should handle those. Those are a little bit tricky, situation, and sometimes, it could deteriorate their performances. So we really want to make sure what to follow and how we handle those. Those consistency requires more arrangement and also preparation to make sure the operation side of it for us. The other thing is it's kind of as as Rick mentioned, overcoming the sense of priority between operation and system building. Because we want to change something now, but making system mean we got to have not only the flow basis situation, more for stock basis situation for us. So system designed to be more long lasting and effective for the making not only the flow basis benefit, but also for more like a stock basis benefit as a not profit, more like a value for us. So overcoming those is a little bit different. How to prioritize the system and feature development whatsoever, that is very tough for us right now. So,
Okay.
thank you.
Thank you. The last question here in this section is for Erica. How do you envision how IIoT supports the factory of the future, and how does network design enable these advancements?
Thanks. So first, let me start with how do I envision the factory of the future. When I hear this, I think about fully automated factories that are self-optimizing. There are robots and machines that are guided with real-time data. There are hundreds of sensors collecting data and correcting and helping to correct the issues in real life at real time without need of intervention. It is a factory that adapts quickly to market demands and maybe customizing products. It uses resources efficiently. And as Seth was saying, this is not about just implementing cool technologies for the sake of it, even if they are really cool. It's about the business case behind it. The manufacturers today are in this constant pressure of improving productivity, adapting quickly to the market demands, and producing things with high quality, all by staying cost competitive. So how can the network be enabler of these objectives? And I see it with my customers, no matter where in the digital transformation journey they are there are some that are just started, there are some that are pretty advanced, but the network allows us to connect devices that were not connected before. So this is the first thing. And this brings automation and monitoring capabilities to the factory. It, as Jerry was saying, now we can bring IT concepts into the OT and start eliminating these silos, allowing us for a flow of information and synergies, right? So the network also provides like a low latency communication for real time and critical processes like robotic arms, conveyor systems. And if you add resiliency and scalability to the mix, then you have a network that is ready for the factory of the future. Through this network, we are able to collect these insights that can be sent to the artificial intelligence platforms to analyze and get solutions on real time. So I think the network is not just the pipes anymore. It has become like the nervous system of this factory. We can use the network for observability, for assurance. We can detect anomalies and provide insights in real time. As I think it was Seth that said he was the happiest when he was in the lab. It's the same in my case. I'm very lucky to work in this multi-million-dollar invest lab, where I get to play with my expensive toys, and I play with new technology so I can guide my customers in it. And for example, one of the latest tools I'm using, it allows us to measure real-time network performance without the need of any extra configuration. So we are not blind anymore. Like before, when we had a customer that had a safety stop in the factory, they will call and start the finger pointing. Is it the application? It is the network. What is going on? But with this kind of tools, we are not blind anymore. We have all the information we need. So I think the factory of the future is not just a distant dream anymore. It's coming, and the network is really important to enable this, so we can step into this transformation.
Rick, is it okay if I share some thoughts on Erica's comments there? Do we have time?
Real quickly, because I'm looking at this. We have two other sections to go, and we're 23 minutes in. So the math, the algebra is not working real well.
Well, I'll just very quickly tell the story to bring some of what Erica said to life, just from my own experience. I was recently working with a power generation company, gas plants all over, right? Multi-state area. And some of those gas plants have good networks and some of them have bad networks. Some of them can support the data feed from all the OT equipment back to the corporate network, and some of them can't. We couldn't for the life of you tell you which one was which. We just didn't know, right? We were blind to the capacity, and right. So having that kind of control plane over our network environment to really understand where we have the capacity and where we don't, it's a big step forward, right? And I think, Eric, I heard some of that in what Cisco is bringing to market, which is very exciting.
Great, thank you. So this next section, we're going to cover how IIoT is operationalized. Also to the audience, don't forget we have the Q&A tab, and that's where any questions you want to ask this great panel should be entered. So we're going to start here when talking about operationalizing IIoT with Shin Nakamura. Can you share examples of how real-time data from IIoT sensors is transforming decision-making and operational efficiency on the manufacturing floor?
Actually, probably the biggest impact is, feedback cycle is shortened, during the shift and also shift by shift. And also we do the roll forming, so roll by roll. So, people used to do their handwriting to report something. It's not, shareable somehow in the real time. But if you're getting all the data from, IIoT platform, we can, get those data from machine directly, and also we can ask something by text or voice data for those. And immediately after input, probably we can process it quickly to, share that to the others and also process to the next shift, next role. Those are very, very impactful for us to, make a more better decision making somehow. The other thing is, more micro level way. Some operation is done by more situation driven or more relying on the people's sense or experiences somehow. But we, for example, like we do welding. People checking the power of the welder by watching the color of the flame before. But right now we can get some more quantitative data, what we call heat coefficient. It's the relation between the power and also heat given to the welding points. One it's going to be more accurate, and also probably we can transfer the experience and know-how one engineer to the other much easier, and that's more crystallized or more visible order changes to the operators, and also other people supporting them. That's very impactful for those. The last thing I can mention is better traceability, because we can for example, like we have some system to mark in individual pieces of the tubing, and if we can integrate all the data by timestamp, we can see what's happened there, chronicle basis, and also from individual machinery, and also product performances somehow for us. So we do what we call trace forward, trace back. So if something happened to the mill, we can check something could happen on the product. And the reverse way, if you find some defects on the main product, we can go back to the system to make sure what's happened to the individual parameters from the all the equipment and machine somehow. So those are the things we couldn't do that much before. We can do those more precisely and also much quicker real-time basis. That is very, very impactful for us.
So, what has been the impact on worker safety?
It's honestly saying it's a little bit transitional things for us. Good thing is, as I mentioned before, we can, to make those systems working, we really need to make sure for the standardize the work. We need, if we get some information coming from the equipment, we need to, take action more standardized way somehow for those. So by doing those, we can have more easier to identify the risk, and that's very, very beneficial for those. And also because those are the real-time information, so probably we can feed the some for example, like a progress of the operation. We can give them some sense of evolving purposes, whether we on time for the production or not. Those are not shared as a whole people before, but they can share those. And especially for if something happened, they can get the feedback at the same time as from the real-time alert or real-time dashboard. Individuals can react to those situations much quicker. So it means, and also people knows about what's happened there and what you should do. So it's more easier to overcome and misunderstanding of the people each other on a line. That would be very, very helpful for us. And also lastly, we can get some individual instruction in a timely manner for those, and we can feed what they should do or what they need to be be aware. That's helped the people to be more focusing on safety side and operation side for those. So they are, if they get used to the system, less lush, and also more easier to switch and off their focus. That would be very, very helpful to make sure about the safety of the people.
Sure. Thank you. Let's move to Erica. How can virtualizing industrial automation and control systems contribute to both cost reduction and improved operational efficiency?
Yeah, so if you walk into a factory today, somewhere in the middle of the action, you will see a PLC that is controlling the production line. It is connected sensors, drives, actuators, and making sure every part of the operation is running smoothly. But as demands grow, the challenges also grow. So maintaining uptime during updates, for example, or scaling resources to add new functionality, new production lines, troubleshooting without halting the operations is difficult. It presents a challenge that is sometimes tied to these hardware-based systems. Now picture a different scenario where we bring the advantages that were brought to the data centers a long time ago already, but we can bring this into the factory floor. What if we can virtualize these assets so an upgrade can be done while you have a machine that is cloned, or you can just spin a new VM when you need to spin a new virtual PLC. So this opens up a world of new possibilities that we are just starting to explore. And companies like Audi are already working in this vision. They already implemented virtual PLC, and they are already seeing the benefits from this reduced physical infrastructure. And I don't think it stops there, like minimizing the cost of the operation. It also brings the opportunity of collecting more data closer to the source. So if you think about integrating industrial IoT platforms that are running on the same data center that the virtual PLC is hosted, then the PLC is not just doing this monitoring anymore. It's also being a sensor for how we are talking, is collecting this data, is detecting anomalies and triggering maintenance before the issues even happen. And again, I think for this, the network is an enabler. And of course, virtualizing the PLC presents new challenges because now we have the virtual PLC on a virtual environment. And then we have the factory floor that is not co-located. So we need a network that can solve the challenge of having a reliable communication, very real time, to guarantee this data. And adding to that, again, we need a network that works as a sensor so we can quickly identify the issues that are happening here. Yeah.
Thank you. That's great. Jerry, building on your comments previously on DevOps and applying that, the DevOps philosophy beyond just IT, what are the most significant cultural and organizational challenge you're seeing that companies are facing when adopting IIoT platforms, or frankly, any technology? And how can these be effectively addressed?
Great question, Rick. So, lot to unpack again. And again, where I go is thinking about people. And the practical approach to bringing a technology in is having the people that are going to use it test it. Before you buy something, have them as one of the, maybe they're not the decision maker, but they are in the room at the table saying, well, this isn't going to work because this reason and that reason. Like just going through the previous examples and hearing Erica talk about low latency, I'm just picturing myself as a worker in a plant that's given a new technology that is said to do all this great stuff, but you're waiting for it to load. And you can't access the data that you need in real time as promised. That is extremely problematic. And when I think about the plant floor, I think a lot about the factory of the future, which will be a symphony of technology orchestrating and operating together. We are not there now. Some organizations have these greenfield plants they've built and they have very thoughtfully put everything together, but the majority, you have this brownfield operation, and there needs to be a lot of thought in what technologies you bring in and how you bring them in and how they operate together. Another example, thinking about what Shin was saying, he mentioned welding. Welding is something that I feel very connected with. I worked as a plumbing and heating tech for years, my family business. I have soldered thousands and thousands and thousands of lines of copper pipe. Today, it seems much easier. My brother is using these fittings that just go together. But there's something to be said about welding, soldering, putting things together. I bring this up because I was thinking about that worker using technology and how welding is done today. At a conference last year, I was able to do virtualized welding, and the machine was able to score me on, what was it, heat, sound, color, and motion. And to be able to do that for the worker, if you bring in a technology that can train them in a safe environment, again, going back to virtualization, and score them in a gamified way so that they can learn, these are the types of technology introductions that are built for success, because that person that's going to use the technology is at the core of bringing it in. And you started the question with the DevOps approach, thinking about how process focused that is. Zev mentioned process in his introduction. You need a good process for anything you are doing, whether that is with technology or just taking out the trash. Time is valuable. You need to figure out that process first, get people bought into it, and then you can bring the technology in to amplify. And while I reiterate it every time I talk, going back to the goal, and Eli Goldratt, he talks about and introduces the theory of constraints. The constraints in your operation are where you need to be identifying first to bring in technology and figure out what that technology can do to optimize and take advantage of that constraint within your organization. And that can be different for everybody, but getting people bought in, getting your individual contributors, testing that technology, and thinking deeply as a cross-functional team, IT, OT, CISO, executives, how that technology and spend is going to maximize your operation. Those are some of the keys, I think, to successfully moving forward.
Great. So finally, we'll go back to Zev for our last question on this section of operationalizing IIoT. And how can we think of the change that an IIoT platform can introduce into an industrial enterprise?
Sure. So I'll pull a thread through that I've been hearing maybe from me and Jerry and Shin around the importance of changing the way people work, right? It's about identifying that process, not putting out tools that are just going to be viewed and not used. How do we get people to actually change their behavior based on data? Jerry, you mentioned gamification as well. I think there is a need for our workforce to change the way they think about their jobs, and this is particularly true, I think, in engineering. Although as we get out to the trades, steam fitters, right, and how they might use automated welding or virtualized welding tools in the way that Jerry was explaining, that's really cool. But it, and particularly for engineers, for people who work for EHS, for anybody who is working in a discipline within a business where they need to understand how the physical world changes, to get them to stop thinking about their job is actually solving the direct problem of how do I get this compressor to work reliably, and how do I get our emissions under control, or how do I manage my supply chain. If I stop thinking about that as my job and start thinking about my job as how do I train a computer to detect the physical conditions that would require a change in what I'm doing with my compressor to make it more reliable, or require a change in how I'm interacting with my suppliers so I have the right inventory in stock, or require a change in my scrubbers so that my emissions are more in line, right? Think about your job less about doing the direct task and more about how do I train the computer to do this task for me. There's a mindset shift there that I think is really important. That helps us get from I'm just going to look at this screen with data on it, and we're just going to put more and more screens of data in front of our operators and hope that they do something smart with it. Get them from there to we're actually pulling computers along as partners with us into our manufacturing plants. I think that's really important. I had another point on that. I think I'll leave it there for then, Rick. Does that kind of get at the question?
Yeah, I think so. All right, thank you. So at this point, we're in our last section before the attendee Q&A. And again, if you have questions you want to ask the panel, go to the Q&A tab on the right-hand side. in this last section, we're going to get to the fun part, I think, which is looking at the future of industrial Internet of Things. Going back to Zev, why are IIoT platforms even more important today than they've been in the past?
Sure. It gets back to what we opened with talking about. There is so much change that manufacturing CEOs are dealing with today. And I think maybe Shin, you'd be even better qualified to answer this question than I would be. And certainly if I'm ever in Tokyo, I would love to see your plant because it sounds fascinating. But you're just dealing with more change. You're dealing with change. We're so interconnected. And we built this tremendous web of interconnectivity over the last 30 or 40 years within our economy, right? Not necessarily talking about network connectivity specifically, Erica, but that's a huge part of it too, right? We're networked together, both in our economy and in our data. And a change in one spot, like a butterfly flaps its wings in Tokyo, and then over here in Nashville, I'm changing the way that I have to operate. How do we respond to that kind of change? We need to respond to the physical world in a way that we haven't before as manufacturers. And we need to respond more quickly. So that's one part of it. And the other part is we need to be able to take advantage of the new technology that's available to us. We did a research as part of Accenture. Accenture released this research from executive surveys. And we looked at the people who had adopted Gen AI technology and were successful and those who were not. And we discovered that the people who are successful in adopting Gen AI just in the last couple of years are the people who have what we describe as a digital core, right? And in the terms of operational technology, that's exactly what we're talking about here in industrial IoT platforms. It's the ability to bring this data together and contextualize it and to be able to very quickly pull out the events that are relevant. And that's how, and it allows you to incorporate new technologies very quickly as well. So it's really those two things. It's one, the world is changing faster and we need to be able to change quicker to changes in the physical world. And two, digital transformation is touching everything and providing new opportunities. The people who can take advantage of that are going to be successful. And that also requires an industrial IoT platform.
Excellent. Excellent. Jerry, looking ahead, how do you see the relationship between IT and OT evolving in the industrial automation space over the next decade?
So I touched on some of this before, and I've been thinking about it since so that I'm not repeating myself. But going back to one of the things that just came up with Zev, that proactive versus reactive approach. I think very much today there's a prevalence to lean on reactive. And I could go deep into this and the psychology around it, Daniel Kahneman, Thinking Fast and Slow, and our different ways of approaching problem solving. And on the plant floor, under the pressure of downtime, maximizing uptime, like we just did a study, the State of Industrial DevOps report, where the average downtime was 4.2 million. And this was very large organizations, very senior executives. So having that purview of not just the line going down, but the cascading impact, whether you need insurance brought in, lawyers brought in because of that downtime events. And trying to put in context the people on the plant floor that are working around that. Oftentimes, I think we are walking on eggshells. We have all of this money being diverted into digital transformation, the expectations pushed onto people to maximize that uptime, to maximize that technology investment is high and painful. And we're working in a skills gap. We have 10,000 baby boomers retiring a day and a real lack of ability for knowledge transfer. So circling back to where I see IT and OT going, I think taking advantage of IIoT platforms, taking advantage of technologies that are newer to the space now, and empowering workers in a way where they're not just getting a technology, but they're getting an experience. They're getting a very clean, clear user experience so that they can operate quickly from the data that they have, so that they can get up to speed quickly by using the technology that they have. And that, again, sorry, Zev, I keep going back to you, but you said a lot of good things. The data, everybody talks about hoarding their data. Like, I think we should have a manufacturing show, an industry show about data hoarders, because what we really need is not all the data in the universe. We need the relevant data, the data that matters and is meaningful. And while that could be a whole other discussion trying to figure that out, I think we know, or at least can start on the path of what is relevant to what role. And I see the increased user experience. The technologies that will be successful will have better user experience. The technologies that will be successful will have a better data experience. And these technologies will be made to unify IT, OT, and cybersecurity. Going back to that proactive, reactive space, I think cybersecurity is a very reactive space right now. And there's so much fear that people will be hit by an attack that it's just shutting down all the gates. As an industrial DevOps platform, we roll in the OT space and we see these blockers of the DMZ zone. But while people think they have it all zoned off, the IIoT devices that are coming in can open up doors and pathways. So rather than taking a reactive approach of trying to shut things down, it's that proactive approach of, we need this technology because it is the future and our competitive advantage. How do we make it work? We make it work by getting the right people in the room. So I see an evolution of how people approach the entire space, and those companies that will be successful will be evolved in their thinking and very collaborative.
Well said. Well said. Now, if you will follow me down this limb a little bit further, let's talk about everyone's favorite topic. We see AI mentioned everywhere. How can AI truly make a difference for companies and employees in this context?
I'll keep this one short because I know we're getting low on time. So just one example, we recently did an AI launch, and it was with the approach of how can AI practically and pragmatically help, addressing all the things we've talked about today, thinking about all those things. So where AI fits in is where it is practical and can accomplish a goal. For industrial code, we went through numerous different examples, not, hey, let's throw a co-pilot in there and we'll see what it does. It was testing and iterating with customers and finding out that code documentation is one of the number one things because it solves for limited time. Nobody has time to write up documentation when they're struggling to just get the code packaged, shipped, and updated. And to be able to do that quickly with this AI tool makes a huge difference. So I think AI, ML coming into the space, it's finding those areas where it amplifies your workforce, it takes away pain that they feel on a daily basis, and it addresses the workforce issues that are prevalent today with a skills gap, so being able to interpret and understand things quickly for someone that might not be highly skilled, and with the retirement and replacement of workers coming in, being able to get them up to speed quickly with summarization and being able to, again, have visibility and understanding of what the function is that they're walking into. And we need to let people know that manufacturing, distribution, our industry is completely awesome and using the coolest technology out there. That is like the number one thing. More people should be flocking to this space. So
Yes.
we need to shout it from the rooftop. AI and ML are in. We are using it. We are developing it. You get to use it by coming to our space.
Yeah, absolutely. You know, you make a really good point, and I remember speaking about a year and a half ago to some execs at a large software company about uses for AI. And while most of the folks around the table were kind of just kicking the tires, one of the things that came out of this, which I found really interesting, is not just code documentation, but code best practices. That if you can look at, you know, the step one, you're doing all the documentation. Step two, well, what's the best way to apply that? And it's not too big a leap to be looking at that from the standpoint of the frontline worker. What are the best practices for these, rather than having some sort of multi-page standard operating procedure, just kind of getting down to the nuts and bolts, the actual task that's being done at the time. So let's turn to Erica on this topic of security. You mentioned that a little bit, Jerry. I don't think it's something that is, it's on everyone's mind, but I think it's part of this conversation for sure. So with the increasing need for integration and collaboration with vendors and partners, what role does network security play in enabling secure and efficient access while maintaining rich data flow?
So yeah, manufacturing is a lucrative target for cyber attacks. In fact, last year it accounted for 25% of the incidents globally. So it should be in everyone's minds. And I think what we see from the Cisco reports, our customers have that as a top priority. Because as manufacturing increasingly integrates partners and vendors and connect all these devices that were not connected before, some of them cannot be patched anymore. So the surface for attacks grows. So a robust network security is essential to safeguard these operations. As Jerry was saying, we don't want to shut the door. We just want to keep things open and collaborative. But how do we do this? So I want to talk about 3 concepts on how the network can help with security. They are visibility, segmentation, and remote access. They are not the only 3, but I think for these OT environments, those are the 3 I like to highlight. So first, we need comprehensive visibility, understanding what devices are connected, what are their vulnerabilities when we don't apply software upgrades, what are the communication patterns. This is key to understanding the security posture. The good news is that we don't need to add new devices for this. The network, again, can be used as a sensor to gain this visibility. Without adding anything extra or doing any span and just congesting your network, you can use the same network as your eyes and ears and identify the anomalies, helping the manufacturers detect and respond before it's too late, before it escalates. Second, segmentation. So there is a well-known standard, the IEC 62443. It defines a solid framework to secure an industrial network. It defines zones and conduits and how the communications should be defined between the zones by a conduit that is policy-based. The user says, this is the communication I want to flow. It's not open for all, right? So I like to imagine it as a music festival. We have different types of passes in a music festival. Some have access to backstage, VIP areas, general areas. So similarly, in a factory, we can assign passes to the devices and users that think about assigning a pass or a tag to those devices. So this tag through a network will ensure that the endpoints have only access to the things it has the right permissions to access. Same way that in this music concert, the security person can enforce and make sure no one enters VIP unless they are allowed. So the network devices can act as enforcement points, only allowing flows that come with the tag that is allowed by these policies. And this is a really important concept because it allows us granular policy design. It's not all of nothing. I can decide, okay, I can have this assembly line communicating with this other part of my factory or not, or maybe just allowing an interlocking PLC cross the boundary while everything else remains isolated but connected, still having this crucial connectivity. So the segmentation is not because lack of connectivity, it's because there is an intentional policy behind it. And finally, I think the network should allow secure access to vendors and technicians so they can remotely maintain and troubleshoot the equipment without compromising security. This access has to be based on zero trust and also be targeted to the specific area or devices they need to access. You can even tie it to a time window. So only this user can access this machine during during these hours. So I think integrating these elements, the visibility, segmentation, and secure access are crucial functions now in the network that create a security framework to allow this collaborative data flow that will allow us to go into this digital transformation without just shutting out the gates.
Thank you so much. We have a couple of minutes left and we have a couple of questions. The first question is actually for Shin. The question is, I'm interested to hear from Shin on whether he has considered predictive analytics, such as predictive maintenance at his steel tube facilities. We conducted a project with Nippon Steel on a stretch reducing mill for predictive maintenance using IIoT sensor data that was successful.
Actually, we do. We try to, especially for, we try to adapt the conditional maintenance, as much as possible using the sensors somehow. Other than those, we combining those. Sometimes, those equipments are very expensive for those. So, we also using the, time-based, maintenance and converging those. We try to, apply the total productive maintenance, system to share the resources to how to maintain those as we go in the real time right now. So, but it's the tough thing is, how to prioritize those individual setting photos and how to integrate those to the, as I said before, the workflow to, getting going forward effectively. But yeah, we do. This is a very, very interesting arena. Availability of the, those assets is very, very critical for the, operation. So we're doing our best to, make it to happen somehow. But it's a very, very, preliminary stages right now. So.
Great. We have another question here. I've got to get back to the Q&A section. Any case for sharing anonymized training data sets between manufacturers to improve our models? It's not pointed at anyone, so if anyone want to kind of dive in on that one.
Rick, can you say it one more time?
Sure. Is there any case for sharing anonymized training data sets between manufacturers to improve models?
That's funny. I was just having a conversation with some of my colleagues internally the other day. We were toying with the idea of using Gen AI to, well, I just got survey to create anonymized data sets for almost this exact reason, for demos and also for model training. I think in general, when I've applied or worked with teams that have applied machine learning in particular to the physical world, it has been hard to make those models useful with simulated data. You really need the actual data from the physical world in order to do it, and you need to have a really intentional combination of first principles physics models with your machine learning in order to make any sense at all. So in that case, I mean, there are actually, NASA's published like a jet engine data set, which is a real data set. It's not anonymized, it's NASA, so it's free to the public. We built a jet engine predictive analytics demo off of that. I think in general, there is a need though for data, whether it's anonymized equipment data shared for model training, or it's data that we're sharing with our OEMs to help with maintenance, or there's this need for a marketplace or a single environment where manufacturers can share data together for any number of hundreds or millions of use cases. And we don't have that today. If I'm a oil and gas company and I want to share data about a joint venture with another oil and gas company, that is hard. I'm poking holes in firewalls and I'm setting up bespoke systems to do that. And that is just like, I need to provide regulatory required reporting data to my partner, right? That's not. So yes is the answer. All right.
Very good. Well, We're a bit past time. First of all, I want to thank Shin, Zev, Erica, Jerry. Great insights today. Thanks for sharing your knowledge. And also thanks to our attendees for listening in and for your great questions. This is the last session, so we hope to see you at a future event with IIoT World. Take care.
Thanks, Rick. Thanks, everybody.
Thank you very much.
Bye-bye.
Thank you.
Bye.